Exercise number 7.1, problem number 9. If Q 0, 1 or the x and y coordinates of Q is equidistant from P and R, we need to find the values of x. Also, we have to find the distances QR and PR. Point P is given as 5, -3 and point R is given as x, 6. So, they have given equidistant, this term. What does it mean by equidistant? Equidistant means at equal distances. At equal distances. Let us see this with an example. This is point A and point B. Let us consider a point P. I can say P is equidistant from A and B when if AP is equal to BP. So, if these two distances AP and BP are equal, I can say P is equidistant from A and B. Similarly, let us take this line segment AB. If P is the midpoint, what is the conclusion? PA is equal to PB. Since P is the midpoint, here also I can say P is equidistant from A and B because PA is equal to PB. So, P is located at a place which is equal in distance from A and B also. Here too, PA and PB are equal. The distance between the points P and B and the distance between the points P and A are equal. So, from those 2 points A and B, this point P is at equal distance. So, this is the meaning for the term equidistant. Now, coming to the problem. Already it is given that Q is equidistant from P and R. So, what does this mean? This means QP is equal to QR because Q is equidistant from RP. So, these two distances are equal. That is, QP and QR are equal. So, I can write, since Q is equidistant from P and R, QP is equal to QR. Now clear? Okay. Now finding the distance QP. What is QP? Q is 0, 1 and P 5, -3. This is x1, y1, x2, y2. Since we are talking about distances, we are going to use the formula distance. What is the distance formula? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. And now, substituting all the values in the formula, D is equal to, that is QP is equal to root of, because we are finding the distance between the points Q and P. So, the distance becomes QP. What is x2? 5 minus 0. 5 minus 0 whole square plus minus 3 minus 1. Minus 3 minus 1 whole square is equal to root of 25. 5 minus 0 the whole square is simply 5 square. 5 square is 25. And then minus 3 minus 1 is minus 4 whole square. 25 plus minus 4 the whole square is 16. Okay, QP is equal to root of 25 plus 16 is 41. Root of 41. And now we are going to find QR. What is QR? Q is 0, 1 and R x, 6. Now x1, y1, x2, y2. In the same distance formula we are going to apply x2 minus x1 the whole square, that is x minus 0 the whole square plus y2 minus y1 6 minus 1 the whole square. So QR is equal to x minus 0 the whole square is simply x square plus 6 minus 1 is 5. 5 square is 25. Let us take this as equation number 1. This one is equation number 2 and equation number 3. Substituting 2 and 3 in 1, which means QP is equal to QR. Here root of 41 is equal to root of x square plus 25. Now we need to find the value for x, so we have to eliminate this square root. So squaring on both sides. If I square on both sides, the square root will get cancelled. So x square is equal to 41. This 25, if it goes to the left hand side, becomes minus 25. X square is equal to 16. X is plus or minus 4. And now we need to find the distances QR and PR. Q is 0, 1 given in the problem itself, and R is x, 6. X, 6. But we have got two values for x now, that is plus or minus 4. So we have to find two values for QR and two values for PR also, because the x value is plus 4 and also minus 4. If x is equal to 4, then Q remains as it is and R becomes 4, 6. Now we need to find the distance between these 2 points, that is when x is equal to 4. This is x2, y2, x1, y1. Same distance formula we are going to use, x2 minus x1 whole square plus y2 minus y1 whole square. All within the square root. Be careful. We are going to find the value of QR. So writing QR is equal to root of x2 minus x1, that is 4 minus 0 the whole square plus 6 minus 1 the whole square, that is 4 square plus 5 square whole root. 4 square is 16, 5 square is 25. So QR is root of 41. This happens when x is 4. And then if x is minus 4, what will happen? Q 0, 1 or minus 4, 6. So the distance d becomes QR is equal to root of, now this is x2 y2 x1 y1, minus 4 minus 0, minus 4 minus 0 whole square plus 6 minus 1 the whole square, which is again minus 4 the whole square plus 5 square, again root of 16 plus 25, and again we will get 41. So both the values of QR, that is the distance between Q and R, are same when x is 4 and x is minus 4. And then now we are going to find the values for PR. PR when x is 4. What is P? P is given as 5, minus 3 and R 4, 6. So this is x1, y1, x2, y2. PR is equal to root of same distance formula x2 minus x1, that is 4 minus 5 whole square plus 6 minus into minus 3 plus root of 4 minus 5 is 1 square plus 6 plus 3 9 square, that is root of 1 plus 81, which implies PR is equal to root of 82. And then PR when x is minus 4. P is 5, minus 3 and R is minus 4, 6. Now this is x1, y1 and x2, y2. PR is equal to root of minus 4 minus 5 the whole square plus 6 plus 3 the whole square, which is equal to minus 9 square plus 9 square, which is 9 square into plus 9 square, taking 9 square as common, root of 1 plus 1, that is 9 root 2. PR is 9 root 2. This happens when x is minus 4. When x is plus 4, the value of PR is root of 82, and when x is minus 4, the value of PR is 9 root 2, and then if x is 4, QR is root of 41, and if x is minus 4, again QR is root of 41. Thank you.